Have you ever just stopped and looked around? I mean, really looked and wondered what everything is made of? Your desk, the air you're breathing, even you? Well, it sounds like a huge question, but it turns out everything in the universe can be broken down into some pretty simple building blocks. Today, we're going to find out exactly what those are. Let's get into it. So here's our roadmap. We'll start with a framework for how scientists classify all the stuff out there. Then, we'll hit the first major fork in the road, the difference between pure things and blended things. We'll zoom in on the absolute purest forms, which are elements, and see how they can link up to create compounds. After that, we'll check out what happens when things are just mixed together. And finally, we'll zoom back out to see the big picture. So yeah, let's dig into this question. If you could zoom in, and I mean way in on anything, a piece of metal, a drop of water, anything, what would you see at the most fundamental level? You might think it's a tangled mess, but actually the system for mapping it all out is surprisingly elegant and simple. Okay, so how do we even begin to organize everything in the entire universe? Well, scientists love a good system, and they've come up with a brilliant one. It's basically a map for all matter. And here it is. This is our guide for today. See at the top? Matter. That's literally everything. Now notice how it immediately splits into two main branches. That's the key. Everything, and I mean everything, is either a pure substance or it's a mixture. That right there is the first big decision we have to make. So this is it, the first great divide. When we look at something, we have to ask, is it just one thing through and through, or is it a bunch of different things kind of hanging out together? Let's break down what that really means. Let's think about it this way. On one side, you've got something like pure sugar. Every single crystal is just sugar. That's a pure substance. On the other side, you've got something like a smoothie. You know, bananas, strawberries, milk, all whizzed up together in one glass. That's a mixture. So what's the scientific difference? A pure substance is defined by its consistency. Every single tiny particle is exactly the same. And because of that, it follows strict rules. Pure water always boils at 100 degrees Celsius at sea level. Always. You can't separate it into different parts using physical methods like filtering. It just is what it is. Now, a mixture is totally different. It's just a physical blend. Think about making salad dressing. You pour in oil and vinegar. You've made a mixture, but you haven't created a new substance called oil vinegar. The oil is still oil, the vinegar is still vinegar, and if you let it sit, they'll even separate back out. There's no deep chemical connection between them. Right, let's head back to our map and go down that pure substance path. If we keep simplifying, what's the absolute end of the line? What's the purest of the pure? Well, that's where we find the elements. An element is as basic as it gets. You just can't break it down any further by chemical means. A piece of pure gold is made of nothing but gold atoms. That's it. You can't split a gold atom and find something else inside that's still gold. These are the fundamental building blocks of, well, everything. And that's the big idea right there. Atoms. Just like you'd use different kinds of bricks to build a house, the universe uses different kinds of atoms to build everything we see. This idea has been around for ages. The ancient Greeks called them atomos, which literally means uncuttable or indivisible. But it took this guy, John Dalton, a British chemist in the early 1800s, to really take that ancient idea and turn it into real science. He's the one who proposed that all matter is made up of these tiny, distinct particles called atoms, laying the groundwork for all of modern chemistry. So we have these atoms, these elemental building blocks. But what happens when they don't just sit side by side? What happens when they actually join forces and create chemical bonds? Well, that's how we get our second kind of pure substance, a compound. This is so important. A compound is not just a casual mix. It's a whole new substance that forms when different elements chemically lock together in a very specific fixed recipe. Think about water. It's always made of 2 hydrogen atoms bonded to 1 oxygen atom. You can't have water with 3 hydrogens. That's just not water anymore. And you live your life surrounded by compounds. Water, obviously. The salt you put on your food, that's a compound of sodium and chlorine, 2 elements that are, by themselves, pretty dangerous. The carbon dioxide you breathe out, a compound of carbon and oxygen. In every case, new chemical bonds created something with totally new properties. And this little group of bonded atoms has a name, a molecule. A molecule is the smallest possible unit of something that you can have that still is that something. A single molecule of H2O is the tiniest bit of water possible. Any smaller, and you've just got loose hydrogen and oxygen atoms. Okay, deep breath. Let's rewind and go back to our main map. We've explored the pure substances, elements, and compounds. Now, let's go down that other road and check out the world of mixtures, where things are just physically jumbled together. This chart really nails the difference. A compound has a fixed recipe. A mixture's variable. You can add a little more of this, a little less of that. A compound is formed by a chemical reaction that creates something totally new. A mixture is just a physical stir, and everything keeps its old properties. This distinction is one of the most important concepts in all of chemistry. Now, even mixtures come in two flavors. You've got homogeneous mixtures, where everything is so evenly mixed you can't see the different parts. Think of salt completely dissolved in water, or the air around us. And then you have heterogeneous mixtures, where you can see the different bits, like a handful of trail mix, or rocks and sand. You know, there's a really cool and super important type of homogeneous mixture called an alloy. This is what you get when you melt metals together, like steel, which is mostly iron and carbon, or brass, which is copper and zinc. Remember, they're physically mixed, not chemically bonded into a compound. And why would we do this? Here's the perfect reason why. Pure 24-karat gold is beautiful, but it's actually really soft. A ring made of pure gold would bend and get scratched up almost instantly. So to make it strong enough for jewelry, it's mixed or alloyed with other metals like silver or copper. We're creating a mixture to get the best properties of everything involved. Pretty clever, right? All right, we have explored all the different paths and branches. It's time to zoom all the way out and look at our complete map of matter one last time. And here we are, right back where we started, but now it all makes sense. You can see how all matter breaks down into either pure substances or mixtures. Then the pure substances split into elements made of one kind of atom, or compounds with different atoms bonded together. And on the other side, mixtures can be uniform or not so uniform. It's a simple but incredibly powerful way to organize the entire physical world. So next time you drink a glass of water, you'll know you're drinking a compound. When you take a breath of air, you're breathing in a mixture. That metal tool in your garage, it's probably an alloy, a special kind of mixture. You now have the blueprint for, well, everything. So here's my question for you. Now that you know the recipe, how does it change the way you see the world? Think about it.